Okay, guys, let's take a look at today's lesson for today. This is day 3 of our related rates. This will be the last one that we'll do in class together for the notes, and then we'll have our daily work and we will move on to a new topic. So hopefully after 3 days we're going to be comfortable and confident on related rates. Alright, so let's take a look at this one. We have a man walks along a straight path at a speed of 4 feet per second. Alright, so it doesn't really matter which way you draw it. I kind of like the positive x-axis, so I just drew it that way. It doesn't give a direction like northwest. Just doesn't say. So it's just a straight path. And I labeled that M. And he's going at a speed of 4 feet per second. So dm dt equals 4 feet per second. Alright. A searchlight is located on the ground 20 feet from the path. Okay, so let me pause right there. So here's my fancy searchlight. And it's located 20 feet from the path. And is kept focused on the man. Okay, so kind of like that. Alright. At what rate is the searchlight rotating when the man is 15 feet from the point on the path closest to the searchlight? Okay, well this would be the point on the path closest to the searchlight at a right angle. We have a fancy theorem about that, but I'm sure that's pretty much logical, intuitive for you. That is the point closest. And we want the rate that the searchlight is rotating. What kind of a rate is that? A rotation rate. Being angular, right? Being angular. So we want d theta dt equals question mark when the man is 15 feet from the point on the path. So when m equals 15. And this is our setup and worth 1 point on a quiz and a test. So let's talk about the setup. Notice this is steps 1 through 3 of the process that we've been working through. Notice that I have my diagram drawn. I have it labeled. I have my rates in terms of the variables that I created. So I have the rate for the man walking and the rate for the angle. And everything is laid out. It's pretty typical. You'll have information, numbers. You'll have the what you want to find, and you have the when. That's just the format. Every single time that you do a related rates problem, if you just follow the format, it'll at least hopefully get you pushed in the right direction. So once we finish steps 1 through 3, remember we do step 4, which is finding an equation that relates all that stuff together. So we look at that. This is our angle measure, and we think, well, looks like we have opposite and adjacent, so probably tangent would be our best bet on this one. So tangent theta equals opposite, which is m, over adjacent, which is 20. Now I just don't want to deal with the fractions, so I'm going to move the 20 over. So 20 tangent theta equals m. Now at this point, let's talk about why I'm able to put a 20 in there. Okay, we've talked about not substituting the constants in before you take the derivative. Only in rare circumstance, and that the rare circumstance is when the distance is never going to change, no matter what you do. So is the searchlight in this problem, now we're not talking about bulldozing anything or moving anything, but is the searchlight going to stay 20 feet from the path? Yes, I can use that number in my equation before I take the derivative. But nothing else. I can't use a number in my derivative or in my equation if it's going to change. Like the angle measure. I can't put the angle measure in there because it's moving. It's going to change. So it's a real important distinction for us that when we can and when we cannot put numbers in before we take the derivative. Alright, so hopefully that's kind of stuck in your head. You cannot put in numbers unless the number's never going to change. Okay, in this case the 20 is not going to change. That's where the searchlight is. That's where it's going to be. Alright, so let's take the derivative. So the derivative of tangent we know is secant squared d theta dt. The derivative of m is 1 dm dt, and there's our derivative. All right, so that was step 5, taking the derivative. Step 6 is subbing all the numbers in. Well, if you see over there, all we have is the rate, dm dt, so that's helpful. But we have m equals 15. That's not the angle measure, so apparently there's some work that we're going to have to do to find that. Now, I like secant and everything, but if we use secant to find our angle measure, I'm going to have to find the hypotenuse. And I just don't really want to mess with that. I mean, you can, if you like secant, you can leave it there and do it that way. But I'm going to change secant squared to use the Pythagorean theorem, and I'm going to change it to tangent squared plus 1 so that I can stick with tangent. So that's what I'm going to do. Just because I'm conserving my energy, right? I'm saving work. If I don't have to find the hypotenuse, I'm not going to. So there we go. So we're going to change secant squared to be tangent squared plus 1. Okay, so let's go over here and let's find our angle measure. So we have tangent of theta equals, now we know this m is changing, but we are interested in this point in time when m is 15. So tangent is opposite over adjacent. So that is what? 3/4. Okay. Now, I don't really need a calculator for this. I don't really actually need to find theta, which is kind of revolutionary, right? We don't need to know what theta is because I know what tangent theta is. And this is tangent theta. Can't I just take tangent theta out and put 3/4 in? Do I really need to find the angle measure? No, not in this case. I really don't. So I'm going to take the tangent theta out, and I'm going to put the 3/4 in. So this would be 20 times 3/4 squared plus 1. d theta dt equals dm dt. Okay. Oh, yeah, we need to do that. We need to put the 4 in. Okay, so we know what dm dt is. It's 4. So now all we have left to do is solve for d theta dt, which is just arithmetic from here on. So we have 20 times, 9/16 plus 1. So I move the 20 over. That gives me a 1/5. And what is that? 16 plus 9 is, 25. So 25/16. I solve for d theta by multiplying by the reciprocal of 25/16. And I get 16 over 125. Okay, so now we go back and look for our units. So what do we think our units are? It's radians per per second. Radians per second. It's a distance. Okay? How are we? We stay away from degrees unless it makes us. If it says put in degrees, then we have to go through that process, but we totally prefer radians. Are we okay?